Hello, everybody, and welcome back to Elementary Statistics Online at Frederick Community College. In this video, I will talk to you about the terminology in Chapter 1, and I will use a very specific example to highlight all the terms, so maybe it will be helpful for you to differentiate between things like population and sample, parameter and statistics, and so forth. So let's take a look at the following page. You see the FCC page and the student demographics listed for you. Okay, so I have some information about students from the fall of 2017. So the college itself collected some information, did some computations, and presented this to the public. So all of this information is public. Okay, let's take a look at my area of interest. So let's say I am interested in the population of FCC students, right? So here's my population of interest. I have capital N that represents the population size, and I know for sure what that is. It's 6,220 students that are enrolled for credit, and I can potentially survey these students, right? And as I survey them, I can ask them things about age, gender, ethnicity, their major, their hobbies, and so forth. Okay? And as I ask these questions, the answers will vary, hence variables. Okay? So these are just some examples that will be variables. Okay? All right. Let's say I am in particular interested in the proportion of FCC students who are bilingual. Okay, and then there's one more thing that I'm interested in is the average number of non-academic books FCC students read per year. So these are some of the characteristics of my population. Okay, my population of interest is all FCC students that are enrolled for credit, right? Every one of them. And these are some of the characteristics. Okay, these numbers, we're gonna call them parameters. P for proportion, mu for the average or mean of the population. And these are characteristics of the population, thus they are parameters. Okay, so I put them right here inside that green circle that represents the characteristic of this group. In my case, this is a population. Also sigma, this guy right here, that would be the population standard deviation. Okay, and in general, these are the things that we don't know. Okay, so P, mu, and sigma, I put it as a question mark. In general, we don't know what they are. And why is that? Even though I know there are 6,220 students, it is unreasonable for me to actually survey every one of them. That's just not going to happen. And quite honestly, it's not needed. It would be unnecessary to do the survey of all these students. That's what census is, right? Census is a collection of data from the entire population. Okay, if I want to know something about the population, I actually don't need to ask every single subject in that population. So what I'm going to do, I'm going to take a sample. So I'm taking a sample from this population, and I could take a simple random sample in many different ways, using a simple random generator. But let's just say I've taken a simple random sample. So let's go down here of 183 students. Okay. I can compute the proportion of students in the sample who are bilingual. So P hat is the proportion of students in the sample who are bilingual. I can compute the average number of non-academic books that students in that sample read per year. I only have 183 students. Okay, that is doable. That is very much doable. I can plug it in my calculator or Excel spreadsheet and compute the mean. Okay, I can compute the sample standard deviation. All of these things can be computed. All of these things we're going to call statistic. Each one of them is statistic. P hat is a statistic. X bar is a statistic. S is a statistic. That's a characteristic of the sample. Okay? Are they basically saying the same thing, statistic and parameter? Yes, parameters are characteristics of the population. Statistics are characteristics of the sample. But what is the big deal? What is the big picture? The big picture is that we want to say that p hat is approximately p, because this quantity right here we don't know. Or x bar is approximately mu. This quantity right here we don't know, but we can compute p hat and x bar if we take a good representative sample, unbiased, okay, with the right size. So we're kind of now talking about slightly different terminology that we're not ready to talk just yet, but we're going to talk about the sample size needed, how we can come up with an unbiased sample, right? So all of these things, but this is the big picture of the inferential statistics. We want to take a sample that's good enough for us to make this approximation, okay? With p hat approximately p and x bar approximately mu. It's not exactly that simple and simplified, but this is just one easy way to look at what we're doing, where we're actually going with statistics, okay? So what you basically just saw now, the big picture of where we're headed to, okay? We want to make some sort of inference about the population. We don't need to survey every single subject, okay? So what we're going to do, we're going to take a sample that the computations are easy to do on, and then we're going to approximate, okay? Approximate our parameter with a statistic, okay? In a nutshell, that's what statistics is all about. And now, after we cover this material, we're going to get into the details, how things work mathematically, why we can do this, how things work under the hood, and what we need to do, what needs to be satisfied, what kind of requirements need to be satisfied so we can make this approximation, so we can make this inference. All right, thank you for watching. I hope this is helpful with the terminology for chapter 1.